All right, so this is the review for second test. Oops, sorry, sliding that away. So number one, we just have to write the equation next to the name. So this is just all straight vocab. But the nice thing is, if you can do this one, you kind of know almost all the equations you need for the test. So this is kind of good to see at first, because if you can do this, you can always refer back to this question for the equation forms. So first one I got is point slope form. So point slope form is the one that goes not x, y minus y1 equals m parentheses x minus x1. So that's our point slope form. So remember, the idea here is that m is the slope, and then our x1, y1, this is a point. So x's always go first, but this would be our point. So again, it's called point slope form because we have the slope and the point. B is slope intercept form. That one is y equals mx plus b. And again, m means the same thing. M is still the slope. B is a little bit different because this time B is the y-intercept. So that's what those mean. Again, you don't really need all the meanings, but I'm just putting it all here just so there's a big review just on this one slide. And then the last one, standard form, is ax plus by equals c. Now again, you might think b and b are the same, but this is little b. Little b is the y-intercept. Capital B is just some integer. So that's just some number. That's all we got for standard form. The one other equation that you might need that isn't on this question, but it is the slope formula. So m equals y2 minus y1 over x2 minus x1. So that's the other equation that you might want to use, and that is for slope. So that's our slope equation. All right, so that's everything we got for number one. So number one, we just have to get the equations. So nice little review of all those parts. Oops, too fast. Two. So we graph our graph. So here it's in slope intercept form. So we know that our y-intercept is 2. So we're going to start at 2. So we're just going to go up 2 and make a dot. And then we also have the slope. So the slope is negative 3 over 4. So from B, we're going to go down 3, right 4. So 1, 2, 3, 1, 2, 3, 4. And then we can just draw a line. I'm going to cheat. I'm going to use the line tool. I'm just going to make a nice little line. And then we'll just extend the line the other direction, right through the blue and the red. If you want to cheat too on the test, just grab a straight edge and then just kind of make a little straight edge between those two dots. But that's it. So again, if you wanted to, you could have flip-flopped it if you wanted to go instead of, we'll make that green. But if you wanted to go instead of going down 3 and right 4, if you wanted to go up 3, you could also go left 4. I usually put the negative sign with the top number, but if you want to, you can. You could go 1, 2, 3 up, 1, 2, 3, 4 over, and we can see we're still on the line. So you can actually go anywhere on the line. It's okay. But that's number 2. Again, if you want, you can graph that in Desmos or in your handheld calculator and look at the graph that way too. For 3, find the equation of line in slope-intercept form through -2, -5, and 1, 4. So if we want to do this, we could do m equals y2 minus y1 over x2 minus x1. So again, the first point is the 1s. It always goes x and y. The second point is the 2s. Again, it always goes x and y. So if we plug them in, we've got 4 minus -5. So y2 minus y1. And x2 minus x1 is 1 minus -2. So 4 minus -5 is 9. 1 minus -2 is 3. I'm going to simplify that to 3. You don't have to, but it just makes sense to simplify it to 3. Then we need to use y equals mx plus b, because it says it wants to be in slope-intercept form. And so this is our slope-intercept form. And we're just going to plug them in. So again, for y and x, we're going to use x1 and y1. So we got -5. This is the slope. So equals 3. x is -2, and then plus b. And we're trying to figure out b. Now, you could also have used this point. Probably would have made more sense to use that point. The numbers look a little bit nicer. Neither here nor there at this point. But -5 equals -6 plus b. Whoa. Plus b. And that's a 6, that's a b. Those look different enough. I'm going to add 6 to both sides to get 1 equals b. So my final answer is going to be y equals 3 x plus 1. So that's what I get for my final result. That is in slope-intercept form. So that's how we do it by hand. Again, this is one that's really nice to do if you want to do it with the calculator. So if we want to use Desmos, what we would do is we would make the table. And we would put in our 2 points. So -2, 5, and 1, 4. And then what we're going to do is type in the code. So we'll just type in our code for this. So remember the code is y1 tilde mx1 plus b. And so we can see right there, I mean, it's on the screen. So m is 3, b is 1. So I'm going to go ahead and steal that. That's what I need this for. So what I can do is just snag this. And we can see that, yeah, okay, this matches up with what we have, right? We got 3 and 1. M is 3, that's what we got. B is 1, that's what we got down here. So that looks pretty good. A little bit easier to do it if you have the graphing calculator, because then you don't have to remember any of the codes or anything. To do that, we'll go into the stat menu. We'll go into edit, and then we got to put in our 2 points. So -2, -5, and then 1, 4. Now, if we do this, we're going to hit the stat button again. We're going to go over to calc. So we're going to hit the right button right here, this little right button. And then number 4 for the linear regression. We want to pick the linear regression because we're doing straight lines. Press enter a few times, and we get the same thing. We get a equals 3, b equals 1. So there we go. And this one's kind of nice because it does tell us the form right here. So put 3 in for A, 1 in for B, and then that gives us the answer. So that's what we got. So that's one way to do it. You do it by hand, or if you want to use the technology, that's how you would have to do it with the technology. So that's a couple different ways. All right. Number 4, write an equation of a vertical line that passes through 10, -17. So the idea here is we have to do a vertical line. So we have to remember what a vertical line form is. So vertical line forms are always x equals. Well, what's the x coordinate? 10. Okay, we're done. That's it. That's all we want to do. If we want, we could graph it and plot it just to double check to make sure that the line does go through the point, but that's all it is. That's all we have to do. For number 5, which values of a, b, and c will ax plus by plus c be a horizontal line through the point for -9? So in this case, we want a horizontal line. So a horizontal line is going to instead be a y equals a number. Well, we don't need a number because we actually know what the number is going to be. We need that number to be -9. So we need to somehow make this y equals -9. So this is kind of tricky, but we did have a homework question that was kind of like this, I think. We want to go ahead and say, well, if I only want y's, I don't want any x's. So somehow I have to get rid of the x. To get rid of the x, we can make a equal to 0. So let's go ahead and get rid of those 2 choices. From here, I mean, honestly, we can just kind of test them out and see what they look like. If the answer is C, the equation would be 0x plus 1y equals -9. So we said 0 times x is 0, 1 times y is y, and we get y equals -9. That actually looks like that's going to probably be the answer. I'm probably going to circle it, but just to double check, let's check out what D is. 0x plus 1y equals 4. Well, this is going to be 0 plus y equals 4. Y equals 4 is not what we want, so we don't want that to have to be our answer. Oops. Right, y equals 4. So we're not going to pick B, so we are going to pick C. So our first choice here was right. Again, if we wanted to, we could double check with the other two. The other two, if we just try one of them, let's say we try A, we would get 1x plus 0y equals 4. And that would give us an x plus 0 equals 4. X equals 4 is true, but it's not a horizontal line. Horizontal lines are y equals. So we know that's got to be false. So C is the right choice. If you're really in a pinch on this one, again, if you can set them up, so if you just plug in the A, B, and C, you can just graph it and see which one actually works. Like it's fine to do that too. So that would be a good thing to try as well. So there we go. All right, for 6, we have to do an equation in point slope form using the point 2, -1. So y minus y1 equals mx minus x1. That's our point slope form. And here we've got x1 and y1. So remember, it's always x first, then y. So y minus -1 equals mx minus -2. So y plus 1 equals m x plus 2. And now we need to find m. We just need to find the slope. So I'm at the point -2, -1. And here now I just kind of count slope. I got to do rise over run. So from here, I can go to the right or to the left. I almost always like going to the right if I can. And I see down here, looks like I got another point. So I'm going to do the rise and the run for that. So to get there, I might have to go down 2. And then over to the right 1. So -2 over 1. I want to do that in red, but it's all right, -2. So y plus 1 equals -2, x plus 2. That's in point slope form. So we don't have to simplify it. We don't distribute the 2 through because we don't want to do intercept form. We just want point slope form. So there we go. That's it. Pretty nice. All right. Number 7, what's the equation? Again, in point slope form of a line that passes through the point and has a slope of 9. So this one's pretty quick because it's y minus y1 equals mx minus x1. And just like last time, they gave us x1 and y1. But this time they were even nicer. They told us the slope. They told us that m is 9. So we're kind of already done. Y minus y1 is 3 equals m is 9. X minus -8. And that's a fine answer, but I'm going to make it look pretty because I don't like the 2 negatives. So x plus 8. That's it. So that's another very quick one. So very fast. If you want to double check that you got the right answer again, you can graph it and make sure it actually goes through the point and has the right slope by counting. For number 8, so again, point slope form. So this time we have to pass through the 2 points. So to do this, we need to get the slope first. We need to get m. So this is y2 minus y1 over x2 minus x1. So y2, let's label them. So this is the first point, x1, y1. This is the second point, x2, y2. So 5 minus 3. That's not a very nice 3. That'll do. Over -7 minus -8. So that's going to be 2 over 1, or 2. I want to do that in red. That's our slope. And so then we have to do point slope form. So y minus y1 equals m x minus x1. So y minus, so let's see, y1 is over here, it's 3. M, the slope is 2. X minus x1 in this case is -8. And just like the last one, I want to make it look a little prettier, so I'm going to go ahead and do that. Y minus 3 equals 2 parentheses x plus 8. There we go. Now, I didn't have to use that point. If I wanted to use the negative 7.5, I definitely could use the negative 7.5 if I wanted to, but that's what we got. And again, if you forget this one, this is another one where if you wanted to, if we throw it into our calculator here, so let's come back here and go to the stat menu again. We'll go to edit, -8 and -7 were the x's, and the y's were -5 again, which is nice, and -3. If we do stat over, that's not over, pick number 4, enter, 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 we can see we get 2 and 11. Now this isn't the answer, because again, we don't want it in y equals mx plus b form. So a couple things we could do. We could be super creative, and we can say, well, I know what the y-intercept is. The y-intercept is just the point 0, 11. So, I mean, we could be super creative and write the equation y minus 11 equals 2, x minus 0. That's if we're going to be super creative. But what we could do is be very sneaky and see, all right, a equals 2, that's the slope. That's just going to give me this number. So if I forget this, or if I just don't want to do this, I can use the calculator to help me out a little bit. Same thing works with Desmos too. If we put the points in for Desmos, we'll get the correct slope. So at least you'll know the slope. And I mean, from there, if you know the slope and you've got the point, it's just the same as this one where it was just this easy. We just plug the number in for m, plug the point in for x1 and y1. So some interesting ways that you can get around some things in case you forget this slope formula. For number 9, we want to make a graph. Obviously, if you want to graph it using your calculator, you can. I honestly think it's better to do by hand than with the calculator when it's in standard form like this, because we just set x equal to 0. So we get -6 times 0 minus 5y equals 30. So -5y equals 30. Divide both sides by -5, y equals -6. Like this is, oops, that's not y, that's the x. So we'll come down here. That's going to be our y-intercept at 0, -6. That's pretty quick to graph. Same deal, we make y equals 0 now. So -6x plus 5 times 0 equals 30. -6x equals 30. Divide both sides by -6 this time. X equals -5. So -5, 0 is the x-intercept. And again, I'm just going to go ahead and draw the line between the dots. That's it. So I don't know. I find the ones that are in standard form to be kind of nice to do by hand, but your call. Just again, in terms of vocab, this is the y-intercept. It's got a y and not an x. This is the x-intercept. It has an x and not a y. Or that's where it hits the x-axis. This is where it hits the y-axis. All right, 10, write the equation in standard form of the line that has x-intercept 4 and y-intercept 5. Okay, well, standard form makes sense. So it's going to be ax plus by equals c. Seems pretty good. But now is where things get tricky. So this one is intentionally trying to trick you. It's trying to have you pick 4 for x, or sorry, 4 for a and 5 for b. But that's not the case. That actually won't work out. So what we want to do is we want to come up with some numbers for a, b, and c. Well, so we know at the end, we know we want the point 4, 0 to work. And here we know we want the point 0, 5 to work. So what could we do here? Well, we do have 2 points. So if we really wanted to, we could find out the slope and then work our way all the way backwards. But there is a nice little method that we could use. Because if we think about how we got to these things on this slide, we got to them by dividing. So if I want to go backwards, I should probably just multiply those. So I can do 4 times 5 will give me 20. I want that 20 to be a purple 20. So this is actually going to be the c value. Okay, so you might be thinking, all right, well, that's pretty interesting. So ax plus by equals 20. So we just kind of multiplied some numbers together. That's fair. That seems like that's a doable thing. But how are we going to get a and b? Well, if the x-intercept is 4, what I'm going to do is plug in 4, 0 for x and y. So a times 4 plus b times 0 equals 20. Well, that means this is 4a, this is 0, equals 20. Divide both sides by 4. A has to be 5. Interesting. But that's not all. Because if I want, I could have done 0, 5. I can put 0 for x and 5 for y. And this gives me 5b equals 20. Well, if I divide both sides by 5, that means that b has to be 4. So that means, using these two answers, it must be a is 5, b is 4, and that's our answer. So kind of interesting. So that one's kind of a weird one to do because we kind of have to work backwards. We didn't do a lot of practice with ones that look like this. But this is one that you got to kind of think about. Now that we've done one, though, like if you analyze it, it's actually pretty quick. Like it turns out the 4 actually doesn't go with the A. The 4 just goes with the B, even though it's kind of backwards. And the 5 is the y-intercept. 5 actually went with the A. So they just kind of flip-flopped. So it's actually a pretty quick one. Again, once you can see the pattern, once you can use that repeated reasoning to see all those patterns, this one actually is pretty quick. But this is one way to do it. Again, if you're totally lost, I would say since you know those 2 points, just kind of find it in either standard form. Well, yeah, it would be slope-intercept form. So find y equals mx plus b, and then try and work your way backwards to get into the right ax plus by equals c form. But that's what we got for number 10. All right, for 11, well, we kind of have to do exactly what I just said. What is the equation in standard form of the line y equals 2/5 x plus 6? So the first thing to remember is that when we do this, we always want a whole number for x. So I don't want this fraction here. So that means I'm going to multiply everything by 5. The reason I'm multiplying by 5 is because that's the denominator here. So I get 5y equals 2x plus 30. Now, the other thing I got to do is I got to get the x and the y on the same side. That's pretty quick. We minus 2x both sides. So negative 2x plus 5y equals 30. And then the other thing we said in class is that we want the x's to be positive. So that means I'm going to switch all the signs. To switch all the signs, I effectively divide everything by -1. Or I guess it makes a little bit more sense at this point to just distribute a -1 to everything. Multiply everything by -1. But this is going to give us 2x minus 5y equals -30. And that's it. So it's a pretty easy question, but it's also an easy one to miss because it's an easy one to forget that the 2 has to be positive. So we have to switch all the signs in order to make it positive. Sometimes you don't multiply by -1 because the x is already positive. So you just got to watch out for that. But anyway, that's number 11. If you want to double check to make sure you got the right answer, it's actually kind of nice. I'm actually going to type in here y equals 2/5 x plus 6. And I'm going to type in 2x minus 5y equals 30, -30. We can see that those two lines just completely overlap. I can even turn the blue one off and turn it back on. And remember from before in Unit 1, we said if we got 2 overlapping things, that was kind of all real numbers. Well, in this case, if you have 2 overlapping lines, remember that means they're the same equation effectively. A little bit of a preview for some stuff we're going to do later. So it'd be all real numbers. But if they overlap like that, that means they're the same line. That means they're equal. So we know that what I started with is exactly the same as what I ended with. So I haven't changed anything. I just changed the form. All right, next one. What are the x-intercept and y-intercept of this graph? Again, we could graph it and just kind of find them. That's pretty quick. But by hand, honestly, I think is going to be even quicker. Because again, we'll just do 6x minus 9 times 0 equals -54. So 6x equals negative 54. So x is negative 9. So the x-intercept is negative 9, 0, or just x-intercept is negative 9. Same deal, we just do with the y's. We just make the other one 0. So 6 times 0 minus 9y equals negative 54. 9y equals negative 54. Divide by negative 9. Y equals 6. So the y-intercept is either the point 0, 6, or we could just say that the y-intercept is 6. So that's it. So that's pretty quick. Again, you can graph it and graph those points as well. Just remember, when you do the x-intercept, you only care about the x. When you do the y-intercept, you only care about the y. 13, Jill has $60 to spend on jewelry. Earrings cost 6 each and rings cost 10 each. So right away, I see we've got two separate items. Probably a good candidate for standard form. And that's exactly what A says. What equation in standard form determines the number of earrings x? Oops, I want that in blue. And the number of rings y she can buy. So again, we'll just start off with the equation. AX plus BY equals C. So X is going to be the earrings. So they cost $6 each. So 6X. Rings are $10 each. So 10Y. And C we said was the total. So C is 60. So there we go. So that's it. We're kind of done with part A. Part B, which of the following represents a possible combination that Jill can buy? Select all that apply. Again, we're just kind of testing them to see if they work. One of them is glaringly not going to work, and that's if we logically think about it. You can't really buy 5 halves of a ring, so no. But we'll test out the other ones. Remember, these are going to be the x's, and these are going to be the y's. So all I'm going to do is plug them in. So 6 times 0 plus 10 times 6 equals 60. So we're trying to figure that out. 6 times 0 is 0. 10 times 6 is 60. And then 60 does equal 60. So A works out. We're going to pick A. All right, so that would be next. So we got 5 and 3. So again, we're just going to plug them in. So 6 times 5. I guess technically Cal was next, but that's all right. We'll work on this one. Plus 10 times 3. And we have to find out, does that actually equal 60? Well, 6 times 5 is 30. 10 times 3 is 30. And yes, 30 plus 30 is 60. So 60 does equal 60. So I'm going to pick Sa as well. All right, then we'll come down here and pick Ka. So we got 2. So we got 6 times 2. And we got 5. So plus 10 times 5 equals 60. So 6 times 2 is 12. And then 10 times 5 is 50. So we have to see if that's actually 60. In this case, this is going to be 62 is not 60. So we do not pick this one. That one's out. The Ka's out. So that's it. That's how to do that one. Again, I didn't bother with the fraction because it doesn't make any sense in context of the problem. If you try it out, it also doesn't work. You may have noticed also, you might be thinking, well, wait a second, couldn't you just buy like one of each? And yeah, she can. We'll get into some of the inequalities a little bit later. For this one, if the answer is wrong, it will be too much just to get rid of that confusion. And then you might also think, well, are you allowed to buy just like one earring at a time? And yeah, you can buy one earring at a time. That's fine because some people like to mix and match earrings, and some people have maybe like 2 piercings on one ear and maybe 3 on another. So you don't always have to have the same number of earrings in each ear as well. So you can buy one earring by itself. You don't always have to buy them as pairs, even though they normally come as pairs. So there we go. All right. So let's see. So for 14, determine whether you're parallel, perpendicular, or neither. So step 1 is to not graph them. So you might be tempted to graph these ones, but remember, if you graph them, perpendicular is going to kind of trick you. because they could cross. They might look like they cross at a 90-degree angle, but it might not be a true 90-degree angle. It might only be 80 degrees. So we don't want to actually graph these ones until the very end if we really want to be sure, but I wouldn't graph them at all. I would just use the algebra to figure it out. So to do that, we want to make sure we get these into y equals form. So what I'm going to do for this one is add 8x to both sides to get 2y equals 8x plus 24. Then I'm going to divide everything by 2 to get y equals 4x plus 12. So what I have to do is I have to look at the slopes. So I'm going to call this one equation 1. So the slope of equation 1 is 4. Now, if they're parallel, so remember the definition for parallel, we have m1 equal to m2. I'm going to call this one equation 2. If they're perpendicular, the rule is m1 is equal to negative 1 over m2. So that's where we're going to flip the slope and switch the sign. If it's neither, that means it's neither of these ones, if others don't work. So you kind of want to go down the line this way to check. So first you check if they're parallel. If they are, pick parallel. Then you try perpendicular because that's a little bit more work. If they're perpendicular, pick perpendicular. If neither of them work, then you just pick neither. So again, m1 is 4. So m2, well, this is already in slope-intercept form. So m2 is negative 1/4. So is 4 equal to negative 1/4? The answer is no, so they are not parallel. So perpendicular would be up next. So to do that, I just like to work with m1 and then finally figure out what I'm going to end up with. So the first thing I'm going to do is I'm going to flip it. So if I take the reciprocal, 4 becomes 1 over 4. Because remember, if there's just a number by itself, that's 4 over 1. So we flip it to 1 over 4. And then we switch the sign. So 1/4 becomes negative 1/4. So since I've done all those operations, we're checking is negative 1/4 equal to m2. I guess I'll put that one in purple. Equal to negative 1/4. Yes, it is. So I would pick perpendicular. Since I've picked one of the two, I don't pick neither. We'll make this one a purple negative 1/4. So that's what we want to do. So that's how to figure those ones out. Again, that's kind of the most work that you would do on this. Obviously, you want it to be parallel because you just want to pick the first one. Then you don't have to do this business over here. But in this case, we had to. Again, the reason I don't recommend graphing it is it might look perpendicular, but it might not actually be perpendicular. It's a possibility. So you can't always trust your eyes with perpendicular. All right, for number 15, which lines are parallel? Select all that apply. Again, I'm gonna recommend you don't graph it because something might look parallel, but then you zoom out and it actually does cross like way out at 1,000 or something. So what we're doing for parallel is just checking to see if the slopes are the same. So just like the last one, we want to try and get the y by itself because in slope-intercept form, it's really easy to see the slope. So 4y equals negative 12x plus 11. Divide everything by 4. And we get y equals negative 3x plus 2.75. Again, I don't really care too much about this because I'm just checking for parallel. I'm not going to try and throw you off by having the two lines that are exactly the same, which if you thought about that, congratulations, you're thinking ahead to the next section. But our slope here, this is the slope. So m is negative 3. So all we want to do is find out ones that have a slope of negative 3. This has a slope of 3. We are not picking it. This has a slope of 3. We're not picking it. This is in point slope form, but that's okay. This has a slope of negative 3. We are good to go on C. That one looks good. This one is in standard form, so just like we did here, I can't just pick this yet because I have to make sure the y is by itself, or I could get into this point slope form. So what I have to do to check that is I have to add 3x to both sides. Y equals 3x plus 5, and we can see here now Nah, not quite. M is just regular 3, so we don't pick that one. So that's how to figure that one out. Again, don't really recommend graphing it, but you can do that just to double check. But I would trust the math over the pictures. For 16, write the equation in slope-intercept form of the line that passes through 15,3 and is parallel to the graph y equals 5/7 x plus 21. So since it's parallel, again, remember the idea is parallel means that the slopes are the same. So since I know the slope is 5/7 of this one, I know the slope for the other line has to be 5/7 for both lines. Okay, well that seems pretty good because now I've got a point and I've got a slope. So it'd be really nice if this question just asked for point slope form because we could be done right there. We could just write it in point slope form. But we got to do y equals mx plus b because that's what the question is going for. In this case, this is the x, this is the y. So we get 3 equals, slope is 5/7, x is 15 plus b. All right, and this one doesn't look like it's super friendly because again, we've got the 5/7, so that's not going to help us out too much. So we're going to have a fraction at the end, but 3 equals 5 times 15 is 75/7 plus b. So we're going to minus 75/7 from both sides. So that's 21/7. So 75 minus 21 is 54. So we get b equals 54/7. So to finish it up, we have to put it back into y equals mx plus b form. So y equals 5/7 x plus 54/7. That seems like a pretty weird answer, so I'm just gonna double check it, just to see if that's actually right. So I got 5/7 x. That doesn't look nice. Let's make it look like a fraction. 5/7 x plus, no, that was minus 54/7. All right, then I'll graph it. Okay, well, that's what the graph looks like. I gotta get out to 15 comma 3. Well, I guess I could zoom out. That's fine. Zoom out to 15. Okay. And I'll hit the trace button. And at 15, well, the y value is 3. Okay, that seems like that works out then. All right, pretty nice. Might be a little faster just to jump to the table. Just kind of scroll down to 15. Okay, 15.3 is on there, so that works. If you're using Desmos and you want to double check that, I need to double check myself. It's a minus. I typed it in the calculator right though. So 5/7 x minus 54/7. So we would type it in here, 5/7 x minus 54/7. And we want to go through 15 comma 3. And again, we're going to kind of slide. There we go. We can see, yeah, it goes right through it. So that looks pretty good. All right, so we double checked our answer because again, that's kind of a weird answer, but it does work out. So seems pretty solid. I'm going to stick with it. So there we go. For 17, line V passes through the point 2,7 and is perpendicular to the graph of y equals 5/6 minus 4. All right, so this is our starting slope. So if m equals 5/6, to get the perpendicular slope, remember we're going to do negative reciprocal. So we're going to flip it to 6/5, and then we're going to switch the sign to negative 6/5. So the perpendicular slope is negative 6/5. So for line V, since line V is perpendicular, the slope of V is negative 6/5. All right, so we're going to kind of cut that period off right there and head to the next part of the question. Line W is parallel to line V. Well, parallel means that the slopes are the same. So that means this has to be the same as the slope of W. All right, let's kind of cut it off there because that's kind of fact number 2. All right, fact number 3 is it passes through the points 10, 5. So that's an x1, not a y2, x1, y1. All right, well, that's great. What is the equation in slope-intercept form of the line of W? So since we need to get it in slope-intercept form, again, this would be great if it said point-slope form because we already know the slope. We already know the point. But this one wants slope-intercept form, so let's do slope-intercept form. So y equals mx plus b. We know the slope. So this time I have the slope in green, which is the same as the red one here, but negative 6/5. I've got x and y. So y is 5, x is 10. And just like last time, we're trying to figure out b. Now, again, you might be kind of sad. We got negative 6/5. That looks like a fraction. But when we multiply it, negative 6/5 times 10 is actually just negative 12. So our fraction actually goes away. So really quickly, we can add 12 to both sides to get 17 for b. Final answer, y equals negative 6/5 x plus 17. So that's pretty good. So the confusing part is figuring out what to do with all of those parallels and perpendiculars. But the goal is just kind of stay slow and steady. So just kind of take it nice and calm, one step at a time, and then you'll be all good. But that's what we got. All right. 18 is the last one, I believe. Yeah, that's it. What's the y-intercept of this line? Again, most people are probably just going to choose to graph it. I would highly recommend graphing it. We had this when we did the quarter term. Like, you should have just graphed it. For those that didn't graph it, they actually got the right answer when we did the quarter term, though. They had the right idea. So, I mean, nothing wrong with doing it algebraically. Plus 20 minus 6 both sides. So y equals 5x plus 14. And then it's y equals mx plus b form. So the y-intercept is 14, or if you want it as a point, 0, 14. Either one would be good. So that's everything. So that's everything we got for that one. Going back to the very beginning, just because it's good to just kind of do the little quick recap. Remember, this was kind of all of the equations that we needed to know. If we want to add a couple more facts, the only other facts that we would add would be parallel, is that the slopes are the same. Perpendicular, the slopes are, the math word for it is going to be opposite reciprocals. But if you want to think about it in terms of what you actually do for the perpendicular slopes, we're going to flip the fraction and then switch the sign. So that would be our key there. Again, our symbols, I didn't use the symbols for just going through, just in case people forgot the symbols, but those are the symbols for them. Parallel is the 2 up and down lines, and perpendicular is it looks like an upside down T, but it's really just like a horizontal line and then like a vertical line, just showing that they're at a 90-degree angle. All right, that's everything we got. That's the entire thing.